Conservation of momentum. Now remember, momentum is always conserved in a system of objects. We never lose momentum, we never gain momentum if we're talking about a system. Now inside the system, that system's made from objects. And of course, an object within the system can lose its momentum to a second object, and the second object in turn will gain momentum. So there's an exchange of momentum between objects inside the system. So here's a graphical example. Imagine one object loses its momentum. Well, an object can lose its momentum, but only if it's able to give its momentum to something else. And so it gives it to object 2. But the whole system right there maintains its overall momentum. So if the entire system is not moving, that means the entire system has 0 momentum. But if the entire system is in fact moving, then the entire system maintains its momentum. So a system does not gain or lose momentum, and a system is made up of 2 or more objects. So the momentum formula, that's this down here, keeps track of how the momenta of objects is transferred between the objects while keeping the total momentum of the system constant. So objects 1 and 2 are exchanging momenta. So initially, object 1 has its momentum, object 2 has its momentum, and they undergo a change which affects their velocities. And you end up having a new velocity for object, this should say 1, for object 1, and object 2 will have its final velocity also. So the total initial momentum is going to be equal to the total final momentum, and that's what this is. So this is the formula for conservation of momentum. The sum of all the initial momenta is equal to the sum of all of this final, that should say final momentum. So be aware that a system can have momentum, that means the system is moving, while the objects in the system exchange their momentum. So here's another graphical example. So imagine object 1 transferring its momentum to object 2. So that means the velocity of object 1 will decrease, while the velocity of object 2 will increase. And that can all happen while the entire system is moving along. So this is like what's happening inside the train while the entire train is moving.